In this video, we're going to be finding equivalent fractions and decimals. Some important vocabulary when we're talking about decimals. There's two types. There's the terminating decimal. That's one that comes to an end and doesn't repeat, like 0.25 or 0.125. It just stops there. And then there's the repeating decimal. That's a decimal that continues on forever and with the same pattern. In this case here, we have repeating threes. This bar over the top indicates that that is what's repeating. It really could have also been written, since it's just the number 3 repeating, we could have just done this. That's all it is. And here, there's a pattern that's repeating. It's 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, which, again, we could have rewritten it, since it is only a 2-number pattern, as 5.24 repeating. Point is, it doesn't matter how many numbers you have here, but if there is a pattern and it repeats, then that's where you're going to, that's how far you have to do it to do the bar. Generally dividing by 7, just as an interesting tip, is going to be one of the longer ones, where you're going to have a lot of numbers to go out that you'll have to put the bar over before the repetition begins. So let's do a few of these. 3/4. Well, to convert it into a decimal, we need to divide. 3 divided by 4. Obviously, 3 is smaller than 4, so we're going to have to incorporate a decimal point. If you remember from the video on dividing decimals, we're going to stack those decimals vertically, and we're going to add a 0 right here. And we want to see how many times the number 4 goes into 30. Well, let's see. 4 goes into 28 7 times. 8 times would be 32. That's too big. So we're going to say 7 times, and that's going to be 28. 30 minus 28 is 2. Since there's still a number there, we're going to need to keep going. So let's put another 0 after that 3. So now it's 3.00. So we can bring that down. And look at that. 4 goes into 20 5 times. So 3/4 equals 0.75. All right. Now I'm going to erase some of this here, at least the work part, because we're going to need this space to do this next problem. 24 over 36. Golly, those are some big numbers. But you know what? Why don't we go ahead and reduce the fraction first? That way we don't have to deal with things as large. I think the number 6 goes into both of them, doesn't it? Let's start with that. 6 times 4 is 24. 6 times 6 is 36. 4/6. Could we go any further? Yeah, 2 goes into both of them. 2 goes into 4 twice, and it goes into 6 3 times. What we're really looking at here is the fraction 2/3. Okay, so 2, and I'll just get rid of all of that. What we're really looking at is the fraction 2 over 3, which is 2 divided by 3. And once again, we're going to need to add a 0 after a decimal. 3 goes into 20. Oh, excuse me. Don't know why I did that. 3 goes into 20. Well, let's see. 3 times 6 is 18. 3 times 7 is 21. That's too big. So we're going to say 3 times 6. Here's 18. Huh. It's the number 2 again. Well, I know we put a 0 here. And we put a... Well, it's 20 again. How many times does 3 go into 20? Still 6. Okay, still 6. And 6 times 3 is still 18. And 20 minus 18 is still 2. And then we bring down... Is this one ever going to end? No, this is one of those types that we're calling a non-terminating decimal. Okay, so if you want to give the exact answer, we can say that this is 0.6 repeating, but instead, since this asks us to round to the nearest hundredth if necessary, and we know that the next number in this pattern is going to be another 6. Hundredths is 2 decimals, so it's 0.67. Because this number 6 is larger than 5. We round up. So the number 24/36, or 2/3, is approximately 0.67, or it's exactly 0.6 repeating. Let's do a few more. 2/9. That's the number 2 divided by 9. Put our decimals in place. 9 goes into 20 twice. 2 times 9 is 18. It's another 2. I think we have the exact same pattern that we had on that last problem. It's going to be a whole bunch of 2's. So we can either call this 0.2 repeating if we're looking for the exact answer, or rounding it to the nearest hundredth, that's just going to be 0.22, approximately. All right. And now let's take a look at this next one here. We have a mixed fraction. Now, mixed fractions, you might think they'd be a little bit tougher. Usually you're probably thinking I have to change the mixed fraction into an improper fraction and work at it from there. But the reality is you don't. I can already tell that the answer is going to be 2 point something. How do you think I could tell that? There's a 2 in front. We have a whole 2 of whatever it is before we have 4/5. The 4/5 is the decimal part. We know it's going to be 2 point something. So we can just ignore the 2 for now. And we want to find out how many times the number 5 goes into 4. Or 4 divided by 5. Well, let's get our decimal in place. 4.0. And the number 5 goes into 40 8 times. And it goes into it 8 times exactly. So we have a 0.8. So what's the answer? Is it 0.8? No. Remember what we started with. It's 2 point something. 2.8. And that's converting that number into a decimal. So how do we go the other way? Well, the other way we need to know a little bit about our place values. This, of course, is the ones place. This next one is the tenths place, the hundredths place, and then finally the thousandths place. So what we really have here is the number 125 over 1,000, because we took it all the way out to the 1,000th place. At this point, we have a fraction. We just need to do a little bit of reducing. And since we're not using a calculator, of course, we're just going to do a little bit of guesswork. One of the tricks, of course, is, well, that ends with a 5. That ends with a 0. I know the number 5 is going to have to go into it. You want to start with that? Or maybe go a little bit bigger, like 25. Yeah, how about 25? 25 is going to go into 125 5 times. How many times does 25 go into 1,000? Well, 25 goes into 100 4 times. So 25 would go into 1,000 40 times? You think so? Okay. So we've got 5 over 40. Well, we can go farther than that. We know 5 goes into 40, doesn't it? How many times? 8 times. So this odd-looking decimal of 0.125 is really just the number 1/8. All right, now let's take a look at this next one here. It's 1.38. And just like on our last problem on the prior page, I'm going to ignore this 1 for now. We know if we were to go with a mixed fraction answer, we know it's going to be a 1 in front and then some kind of a fraction. So let's just deal with the 38. So it's 38 out of, and how many places is that? The 100th place. 38 out of 100. Well, I don't know. Let's just take it slow. We know they're both even numbers, so let's start by doing that. Divide them both by 2. Half of 100 is 50. Half of 38 is 19, I guess. Yeah. Oh, well, that is all they have in common, isn't it? Okay, 19 over 50. But don't forget about that 1 we had earlier here. So one acceptable answer is the mixed fraction 1 and 19/50ths. And if the problem requires it, you can convert that into an improper fraction. But for now, let's just leave it alone. All right. 2 more of these to go. Write the following decimals as fractions in simplest form. How many places out are we here? We're out to the 1,000ths place. And that 0 in front is just a placeholder. We have 42 of those. 42 thousandths. Okay. Well, right off the bat, I can see that they're both even. 42 divided by 2 is 21. And 1,000 divided by 2 is 500. Well, 21 is 3 times 7. Do you think there's a 3 or a 7 inside 500? There isn't. That's the answer, 21 out of 500. All right. And finally, 2 and 2.56. We know it's going to be a mixed fraction, starting with a 2. And we have 56 out of 100. I can see they're both even. So let's just divide by 2 to start with. That'll be 28 over 50. Well, we can keep going then, can't we? We can make that 14 over 25. Yeah, it's not going to go any farther than that, but don't forget about that 2 we ignored at the beginning. So our answer is going to be 2 and 14 25ths. And that is that fraction in simplest form as a mixed fraction. And that's how you can go back and forth between decimals and fractions.